Making API calls in React Native is quite similar to how we do it in React. And we have all the options available that we have on the web version. We can do XML HTTP request, the native APIs, or we can also use fetch, and we can also use popular libraries like Axios. In this example, we are going to use fetch for most of the examples that we are going to see. Before we jump into seeing how to make API calls, there's a particular structure that I recommend using. If you go to our services folder in the application, we will find another folder that is called core. And this is where I recommend implementing all the low-level APIs, as in, let's say we want to make a network call and we want to use XML HTTP request or fetch or Axios or anything for that. So I would recommend exposing simple get, post, and other methods from this particular core service and doing the actual implementation here, as in if we say that we're writing fetch, we implement the fetch over here and expose only our verbs from here. Similarly for storage, let's say that we want to use async storage, which is pretty popular in React Native, or we want to store data into a database, or it may be something else, maybe into a network database that we have on AWS or Firebase or Firestore or anywhere. I would recommend that we create some core APIs that handle and wrap these implementations for the rest of the application to use. So the application can have services like a home page service or product detail service or a checkout service that allows us to add items to cart. And what it can do is it can simply do a storage.get and set. And it doesn't need to care about the actual implementation, whether it's being stored in an async storage or in memory or maybe over a network. That is not what the application is concerned about. And what that also allows us to do is tomorrow, if we want to move from an in-memory storage or an async storage to a database or a network storage, or maybe we want to implement server-side cart and we want to move from async storage to storing the cart for a logged-in user on our server side, all that can be black boxed out from a checkout service, which simply says add to cart. So basically the cart gets saved. It doesn't need to worry about where it's getting saved. So we'll follow that structure and we're going to call that base API. And what this is going to do is it's going to expose some get post methods. So for example, we're going to use an actual mock product responses so that we can simulate a real implementation. So we're going to use some mock APIs. And as we see, there are certain headers that are always required whenever we try to make the call. If we try to make calls for search result or reviews or details, we need to set some headers and verbs. So we can also do these in our base API implementation. So we can set these headers right in a method that's called get default headers. And whenever we call this particular verb, get or post or the others, they know what headers to set before making the actual call. That way, that complexity is hidden away from the rest of the app. And let's say tomorrow we have a requirement to set some new header or a new context. Let's say that we have one more header that adds here, or we need to change the key or the host for that. The services that we implement, like the checkout service and the app service, they don't need to worry about it. All of this will be taken care of. Secondly, what this also allows us to do is, let's say that we want to use async storage on iOS, but something else on Android. Maybe we want to do a database for some reason. Now, if we have a storage service that just exposes different methods like get item, set item, and remove item or clear all, what we can do is we can implement them over here and say for platform equals to iOS, we can have our iOS specific implementations, and for Android, Android specific implementations. So now what the services will do is they'll simply call storage.get and set. They don't need to worry about platform specific nuances. So this structure really helps segregate these service implementations to actual consumption and using them. So we'll try to do a carousel and the data for the listings page or maybe the search page using the fetch. We can also use Axios for that. Axios is a very popular library. It has more than 50,000 GitHub stars. And apart from other things, it also allows to do is it allows you to cancel a network request. And it also has interceptors, as in if you want to intercept the request or the response, you want to modify the response or the request based on whether it's successful or it's failed, we can do all of that. If interested, students can go and look into this themselves. We'll try and do the most common and the most famous one that we have on the web today, and that's fetch. So what we'll do is we'll implement get and post with that, and we'll try to render our respective pages. So let's get started with that. First, we'll go to shared, and here we have the services. In services, we have our core, and then there's an API. It's an empty file right now. And we also have our storage. So for storage, what we'll do is we'll implement the async storage. That's one of the upcoming lessons in this particular module. We'll implement that over there. For this lesson, we'll implement the API, the get and the post. So let's go ahead and do that. We'll say const API equals, let's expose a get method and also a post method. And what we can do is we're going to use fetch for this. So we'll say return fetch, and we will need our endpoint. So let's declare that. And we'll have our endpoint, and we'll also have our, which will be a string, and we'll also have our query params, which will probably be an object. So let's declare that as any for now. So we'll say method get headers. Let's declare that. Let's declare some default headers. So we'll say const default headers equals, and we'll say return. We can simply copy these for now. And over here, we'll say, we'll pick up from the mock response that we're using for this application. What we can also do is we can create a config so that we pull all of this data from that. So in shared services, let's have a new file that's called config. And what we can do is export default and APIs host key. So now we can pull that from there. We'll say import config from config. We'll say config.apis.host and config.apis.key. And now let's call this default headers. Now we have our base get endpoint setup. We also need to pass the query parameters. So it will basically be, let's say that this is an object, then we'll probably need a method to convert that into the query parameter format. So I've already declared a method for that in utils. So let's use that. So we will say, we'll import that and we'll just pass the params to it. What it will do is it will convert that into the query parameter format and then return it. So we have our base get implementation. Similarly, we can do for post. And instead of get, what we'll do is we'll post. And again, we'll have params. Now in post, the params are passed as a body. and we'll say JSON dot stringify, and we'll say params. So that's our base get and post implementations. We're going to use that from one of the services that we declare under services. So let's do that. Before we go ahead, we need to export this. We'll say export default API. Let's go ahead and use this API to implement the search page. Earlier, we had built this page where we had these recent searches. What we'll do here is once we click on any of the recent searches, they'll go to the listings page that we have. And as soon as the listings page loads, we'll make the API call and display the products for that. If we recall the design for the listings page, we had these product cards that we have already built on the home page. So we'll reuse this and we'll build this section for now. So let's go ahead and do that. So before we move ahead, just a little bit about the process that we're going to follow. We're going to create a new service for this, and we can probably call it a search service. We'll create a new one over here. And what we'll do is we'll call it from our thunk. So we'll create a thunk for search and we'll call it from there. Now you might be thinking that we could directly call this service from our search page, right? What is the point of calling it from thunk? But that is not a good idea. Views are supposed to fire an action and they should be black boxed with the actual implementation of the action. They should just care about getting the data or whatever the action is supposed to return. If the action is making a network call or it's getting the data from an async storage or maybe in memory, that's not the concern of the view. So we'll fire an action from our view using the action creators, the thunk, and then thunk will now be responsible for implementing a business logic for that. In this case, it's quite simple. It's just going to call the service that we create for search, but it can be more complex. Now, let's say that when we load the application and we want the cart information for a particular user, there might be two steps to it. The first is we get the token for a user from the async storage. So that's one action. And then the second action is we make a call for that user, validate the token, and then get back the cart for that user. So instead of adding that business logic to the UI and firing two different actions, what we can do is we can create a thunk, and then from thunk, we can manage all that. So that abstracts the implementation out from the UI, and UI only gets the cart information that it requires. So let's do that. Let's create a service. And let's call it search. And we'll say search service. And let's do and we'll have a search term. And what we can do is get, and then we will add the endpoint from our config. So we have this config defined and it has the endpoint for search. So let's use that. So we'll say APIs dot endpoints dot base APIs dot endpoints dot search, and then we'll add the search term to it. Now search term may have spaces and other special characters, so it's always a good idea to URI encoded. We'll say encode URI. And the second one is the param. So we'll pass the params, which is the API key. So we'll say API key. So that should mostly be it. This get endpoint actually returns a promise of a response. So what we need to do here is we need to do a dot then, and we'll say response.json, and we should also add the catch block for errors. And let's console it for now. But ideally, we want to push this to some sort of error monitoring tool, like we'll see Sentry, and we can push it to that. But for now, let's just return a promise, and we'll say error. So our search service should be ready now. Let's now create the thunk for it to call from the UI. We'll go to thunk, and let's just copy over the app one. So we'll say search, and let's go to actions and define actions for this. So you might also do search failed. If the network request fails or we get a bad response from the server side, we can declare that. And we'll go to the search actions, and we'll say and we'll do data. So now we can declare the type for it. We have the types folder. So let's declare one for search. So we'll just have a query, and we'll see search state. And this is the type of action. So we'll just have data dot type of action. Okay, so that's our action. We have defined it. Let's go back to thunk for search, and we will say search requested, and we'll get the action from search, and we need to pass the query to it, data, and then we'll pass the data to it. So that will fire the action for the application saying that we need to initiate a search with this data. Next, let's call the service. So we'll say, okay, we might need to export the search service, and we'll say export. So we'll say search service dot fetch, and this requires the search term, which is data dot query, and this returns a promise. So let's also use async await for this. So that should give us the result, and we will. There are two options here. One is we return the result from here, and that will go back to the UI as it is. The second option is that we dispatch some sort of a search succeeded and pass the data to it, and then we'll go to a reducer, create a reducer for search, and store the data to the application state. Now, search results are not generally required to be stored to the application state because they're dynamic and they keep changing quite a lot. So we'll not do that. And let's go ahead and just return the result. We'll call this particular action creator from UI and get the result. And the UI will directly get the result once it makes a request for a search. So now all of that is ready. Let's go ahead and integrate this with UI. So this is the search page, and what we want to do is once we click on any of these, we'll go to the listings page. So let's do that. We have a list and we also have an on click for this. We want to go to the listings page. So for that, we will go to the router and create a new router method for that. Now this is a good practice. We could either call .push, but what we also wanted to do is we wanted to integrate this button that shows up on the listings page, and that requires an additional top bar and then right buttons. So what we can do is we can reuse the push method, but just add that particular option to it. So what we'll do is we will declare a method for showing the listing screen. Let's call it show listing screen. And we'll say push. The first one is the component ID, which we will get from here. And then the second is pass props. Then we need to pass the ID of the screen that we need to show. So we'll say listings. And for title, what we can do is we can accept the title over here. So it can be title. Now let's use this. So we'll expose it. We'll say show listing screen. Now we can go back here and say router dot show listing screen, and we can pass the title. So we're already getting back the text over here. We can pass that as the title. And for component ID, since we have declared this as a React functional component, we get the component ID in the props. Component ID, props dot component ID. We are not thinking of passing any other props, so we don't need that. And let's save it and let's check. Okay, so we click speakers, we get speakers, we click headphones, we get headphones. Next, let's go to the listings page. And now that we are here, what we can do is we can use use effect to make that call to the thunk and call the search service. Let's do that. Use effect. And as you remember from the previous lesson, that we should always pass a second parameter to the use effect. Otherwise, this will get executed every time a set state for any variable happens for this particular functional component. A good practice would be to always initialize this with an empty array, and we can keep adding the variables that we want to watch for. So let's create that function, and we'll say get API data, and we need to bind that to our
functional component using match dispatch to props. We'll just copy over the type from the home component. And for props, let's just copy over from here. And we'll dispatch the action from our thunk. And we'll say search. This is just a variable name, so we can call it anything that we want. So we'll say string, and we'll say that dispatch that action creator, which is called search requested, and it needs a type of search state, which is query. So now it should be available to us in the props. Let's include that. Before that, let's also move this out. Index, and that should do it. And we'll say search string turn a and it returns a promise. We can also put the search response over here because it's going to respond with that. So let's save it. It should now be available in our props. So we'll say search, and we need to pass the query parameter. How we can do that is, as we saw in the screens lesson earlier, that we can pass data from screen to screen using pass props. Let's go to component and search, and we'll use the pass props parameter. So we'll say pass props, and we'll say query, and the query can be the text that we are using. Now we'll also have the text available as props. Let's call it query and string. And we'll get that. So let's just pass that over. We'll get the response over here, which is of type search response. Let's do async const result equals await, and we can just do set state on that. So for that, we need to declare a state variable for this functional component. So we'll say result set result equals react dot use state. We'll use the use state hook, and initially we can just pass null to it. We don't have anything to initialize this with, and we'll just say, okay, let's change this to response, and we'll say set result. Okay, that should give us the data. And next, what we can do is let's use the data. So we'll say result and result dot results. So it's giving an error because we have not declared a type for it. Let's declare a type. Okay, so we need to do that here. So we'll say search response, which is of type results, and an array. And it doesn't allow a null. So, okay. we need to do this. Results. And an empty array. So what we'll do is we'll just destructure that. Results. And we can just say results dot length. Initially it will be 0. So if it's greater than 0, we can use that. So results dot length is greater than 0. We'll just iterate over it and display the product display module. So right now this particular module is not dynamic. So what we're going to say is the same product, but should at least show up the number of times that we have result, that is around 20. Let's save that. And okay, we also need to call this. So we'll save that. And this should be response. So we'll save that. And let's also add result as watcher. So, okay, that should return the product display as many number of times. Okay, it's displaying the products, but the view is not scrollable. And just copy over the style for scroll view. And we will say scroll view, save it, and that should work. Next, let's do two things. One is we'll make the product display dynamic, and let's also try to render these products side by side. So for that, what we will do is we'll pass the style to the scroll view itself. Now there is an attribute that's called content container style, and we'll use that. We'll say global dot layout dot will declare a style for it. So we'll go to layout and we'll say listing, and we can say flex direction row and flex wrap as wrap, and we'll also do justify content as space between. Let's save that, and we have our listings. So once we save that, we get the products as side by side. Let's also remove the text and the button that we don't require anymore. So that looks like how we want to display this, right? Next, let's also make the product display dynamic. If we look at the search response, what we have is we have the name that we can use for title, and we can use image for image, price for price, and we don't seem to have anything for subtitle, so we'll let it be for now. Let's say title, price, and image. And let's also pull that from props, title, price, image. And let's do one thing. Let's not remove the default values. The reason for that is we have not made any API calls on the home page, so this will stop working. What we can do is we can just say, if you're getting a title, we'll display it. Otherwise, display a default value. And we'll remove this once we integrate the carousel to an API. So we'll say title, and we can do price. Okay, we need to format price. So we'll say dollar price. If it comes, then show this. Otherwise, show a default value. And for URL, image URL. Let's save that. And let's also pass that as title, and price, and image URL, product, and we should have product dot name, product dot price, product dot image. Let's check. Okay, this will be a number. So let's save that. And now if we try again. Okay. The product names are quite long. Let's trim them. So we'll do substring. And that's much better. So we mostly have our listings page set up. So to recap, what we did was we created a core for APIs and we abstracted out the implementation. So we are using fetch right now, but let's say that we decide to use Axios going forward. So we don't have to change anything in the search service because this is only doing an API.get. All we need to do is change the core implementation and the rest of the services can remain agnostic to it. Similarly, going forward, we'll also do this for storage. So we'll implement async storage and we'll use that to store data locally into the application and expose that as a common storage API. So the services don't need to worry about the actual implementation of storage. From there, what we did was we created a thunk for our search, and from thunk, we returned the result. Now, in a lot of cases, we might not return the result and we might want to save it to the state. So for that, what we can do is something like this. So we'll say search successful and we'll create a reducer for this and pass the data to it. And in the reducer, we'll map the data to a store for search. Though in this case, what we want is we don't want to store the search results in the application state. So we are simply returning it to the view. And if we go back to the view, what we have done is we have used a use effect and we have called that thunk from here. So the view is calling an action which basically says search initiated and it just passes the query parameter to it and the rest is handled by the action creator and the services. So apart from that, we can also use Axios and there's a sample implementation over here. It also supports interceptors if we have a use case for that, though fetch works out great in most of the use cases. And next, as an exercise, we can try integrating the categories to the same search implementation. We can reuse the same service, but I would recommend that we implement its own thunk unless we think that both are exactly the same use cases. So I'll do that and push it to the boilerplate repo. That's all for this lesson, and I'll see you in the next one.